Next lesson is 6.5, which is on function notation, and it's a little strange that we've waited until now to do this because we did functions a couple chapters ago, but for whatever reason your workbook waited until now to introduce functions. I might do this differently next year, but it's the first time I've ever used the book, so I didn't know they were going to wait so long. Anyway, function notation. So basically the first thing you need to remember is what's a function. So remember, a function is like a rule, or if you want, a machine if you want. Here's my fancy machine I've probably drawn for you before. And remember, when you throw an input number in, so say for example you throw the number 6 in here, there's some rule attached to this machine, so it makes a different number come out. So let's say 8 came out. Now we don't know right now, but maybe the rule is x plus 2, and that means you take the input value, the x, and you add 2 and you get 8. But I don't know, I'm just making a crazy function that I'm not sure what the rule is. So let's say I put 10 in, and what came out is 10. Is that okay? Sure. You can put 10 in and get 10. That doesn't violate any rules of functions. Your input and your output can be the same. Now let's say you put 9 in, and out came 10, the same amount. Is that okay? Yes, that's okay too. It's fine as long as every input only has one output associated to it. What happens if I put 7 in goes 7, and out comes 2 and 3? Is that okay? No, this is no longer a function, because for everything that goes into the function, only one thing that can come out. If I put 7 in and 2 things come out, that doesn't work. That's no longer a function. Okay, that's basically what a function is. It's a rule that gives output numbers when you throw input numbers into it. Alright, f bracket x. This does not mean f times x. This is function notation. This is how we show that something's a function. And basically what this is it's equal to y. So if you say y equals 3x plus 2, you're familiar with that. That's a linear equation. It would be a line, right? It's in slope-intercept form. Slope is 3, y-intercept's 2. This is the same as f of x equals 3x plus 2. It's just another way of saying the same thing. Now you're probably wondering, well, why do we bother with this f of x then? Why don't we just say y? Well, I would say there's a couple reasons. One is because when you write f of x, you're kind of promising the reader or whoever that this is a function you're talking about. Right? When you just put y, it might not be a function. It is in this case, but you could think of some things that are not functions, and it would actually just a relation, something that violates the vertical line test, right? But with f of x, you're kind of promising this is a function we're talking about. So that's one reason that we use f of x. There's another reason, and I'll explain it to you in a second, but first of all, I need to show you a couple of things. This here, this f bracket x, the way we say that is f of x, okay? And if it was like this would be f of 3. Now, what does that mean? What it means is there's a function named f. So, for example, if we go back to my drawing of the machine up here, it's kind of like I have this function, and I'm going to name it f. That's what the letter up front is. And the input variable is x in this particular function. Okay? So, for example, if I said, well, like this one, f of x equals 3x plus 2, this x in brackets here tells you that in the rule, which is over on this side, there should be an x in it, which is the input value. And there it is. That's the input value right there. And this is where I get to choose whatever values I want to throw into it, 1 or 4 or -2 or whatever. It doesn't have to be f of x. It could be g of x. That means I have a different function, and I'm going to name it g. And I don't know, maybe in this function I'm going to do x divided by 2 plus 1. My input value is x, and there it is. And then I could throw my numbers into x and divide them by 2 and add 1. It doesn't even need to be x. It could be, how about h of m equals. Okay, I have a function which I'm named at h, and there's an input value called m. So you're going to expect to see an m over here because that's my input amount. So maybe it is m squared plus 2 or something. Okay? If you wrote something like this, f of x equals 2m, kind of doesn't make sense that you would do that, because what you're saying is you have a function called f, and the input value is x. But there's no x over here. In other words, there's no input value. There's nothing to do here. What that means is no matter what you throw into this machine, what comes out every time is 2m. If you put 1 in the machine, you wouldn't put 1 here because the only input value you have is x. Alright, I'm going to stop there. That's probably getting a little advanced here. You're probably getting a little confused. Basically, this is how we show that something's a function. Alright, f of 3 means, if it says f of 3, this means find the value of y when x is equal to 3. Like find what the output of the machine is if the input is equal to 3, basically. So again, if I draw my machine up here, f of 3 means if I throw 3 into the machine, what comes out? That's what that means. And how do you figure that out? You solve that by plugging 3 into every instance of x in the function. So for example, if I go back up here, if I wanted to know what f of 3 is, right here, and I know f of x is 3x plus 2, what I do is everywhere I see x in the rule, I put a 3. So I'd have 3, then I put that 3 in for the x, and I add 2. That equals 3 times 3 is 9, plus 2 is 11. f of 3 equals 11. Okay, let's try a few more of those. Given, so here's my function right in here. I'm naming the function f, and the input value is x. So we'd expect to see some x's over here, and yes, there is one x. You could have more than one x, by the way. That'll often happen, especially when we get to grade 11. But it could happen this year too. So if I want to know what f of 5 is, all I'm going to do is plug 5 in wherever I see x. So it's going to be 2 times 5. I'm replacing the x with 5. Take away 3. So f of 5 equals, 2 times 5 is 10. Take away 3. So f of 5 equals 7. Another important fact, you could write this as an ordered pair. Remember, ordered pairs x and y, or if you want, input and output. What was the input value in this case? The input value was 5. What was the output value in this case? Output value was 7. So it is important that you realize you can write it as an ordered pair. Okay, let's do another one. F of negative 2.5. Well, all that means is wherever I see x in the function, I'm going to put negative 2.5. So I have 2 multiplied by negative 2.5, because that's where the x is. That's my input. Take away 3. So f of negative 2.5 equals 2 times negative 2.5 is negative 5. I'm going to take away 3. So f of negative 2.5 is negative 8. There you go. If you threw negative 2.5 into this highlighted function up here, what comes out is negative 8. And again, there's a point associated with it. The input's negative 2.5, so that'd be the first number. And the output is negative 8, so that'd be the second number. X and Y if you want. Okay, now this one's a little confusing. Again, more like grade 11 work, but I love the challenge, you guys, so here we go. We want to know the function of x plus 2. So what does that mean? How do we solve this? We solve this wherever I see x in this highlighted function here, this rule right here, I'm going to put x plus 2. I'll say that again. Wherever I see x, and there's only one place I see x, right here, I'm going to replace that x with x plus 2. So let's do that. So I start by writing 2, and then I'm going to multiply it by x, but instead of writing x, I write x plus 2. So yes, you write x plus 2 there, and then I still have take away 3. Alright, let's see if we can simplify this. We could do some mountains here. Uh-oh, here comes screaming Simone. I'm going to have to stop here. 2 times x is 2x, 2 times 2 is 4, and I'm still taking away 3. So f of x plus 2 equals 2x, and 4 take away 3 is 1, so 2x plus 1. And there's your answer there. Okay, I have to take a break. Okay, it's about 4 hours later and I'm back. Simone's asleep again, so see how much I can get done here. Next question. Given f of x equals 3 minus x divided by 2, determine the coordinates of the point where f of x equals negative 2. Whoa, what's this asking? Well, if you notice over here, it says that f of x equals negative 2. It's not saying the input's negative 2, it's actually saying the output's negative 2. It's like the y value is negative 2, right? This whole amount, 3 minus x over 2, is equal to f of x, and f of x is equal to negative 2. In other words, negative 2, since it's the same as f of x, is equal to 3 take away x over 2. You have to figure out what's the input value for x that would give you an output value of negative 2. So here's an equation that you need to solve. There's different ways you could solve this. You want to isolate the x. I think maybe what I would do is, since it's take away all of this x minus 2, I'd move it to the other side to make it positive. So I'm going to take the take away x over 2, move it to the other side, it becomes positive x over 2. Equals 3 still on this side, and why don't we move this negative 2 over? When negative 2 moves over, it becomes positive 2. Okay, we can combine those terms, so we have x over 2 equals 5. Now, x over 2, that means x divided by 2. So what do we need to do? We need to multiply by 2. So we multiply this side by 2, and we multiply this side by 2. Why does that work? Because if we're multiplying by 2 and dividing by 2, those cancel out. We're just left with x. Perfect. X equals 5 times 2 is 10. There's our answer. We're saying that when you have an input value of 10, the output will be negative 2. Let's see if it's true. You don't have to do this, but why not? We want to know if the input value of 10, so in other words, we want to know if f of 10, whether it equals negative 2. So let's see. We're going to write this highlighted bit right here, but wherever we see x, we're going to put the input of 10. Okay, so that equals 3 take away, 10 divided by 2 is 5. 3 take away 5 is negative 2. So f of 10 is negative 2. Yep, that's exactly what it should be. So we got it right. We have it right. The input's 10 and gives us an output of negative 2. Okay, determine the slope-intercept function. So before we learned the slope-intercept equation, that was when y equals mx plus b. Now we're going to do the slope-intercept function. The only thing different, instead of y, it's f of x. Remember, we already set up here that y and f of x are pretty much interchangeable from each other. They're basically equal to, f of x is basically equal to y. So how are we going to do this? Well, it turns out we actually have 2 points here. It tells us that f of 3 equals 8 and f of negative 5 equals negative 1. So we have 2 points. F of 3 equals 8. What's the input value here? 3. So that's like your x. What's your output? 8. So that's 1 point. Second point, input of negative 5, that's your x. Output of negative 1, that's your y. Okay, so now what our job is to find basically slope-intercept form when you know 2 points. Hey, we've done this a whole bunch of times. The first thing you need to do is you need to figure out what's the slope. How are you going to do that? You're going to do change in y divided by change in x. So take a look at these points, take the y values and subtract them. I'll do 8 take away negative 1. And if I'm going to do it in that order, I have to do 3 take away negative 5. That gives us 8 plus 1 when you have those two negatives, so you get 9. And 3 plus 5 when you have those two negatives, you get 9 over 8. What an awkward slope. I just made this question up and didn't check it before doing it. So I'm sorry, it's going to be a rotten answer, but it still works. Okay, next thing we're going to do is we're going to use slope point or point slope form. So that's y minus y1 equals m, which is the slope right there, times x minus x1. We're going to use one of the 2 points. Which one you want to use? It doesn't really matter. I'll use the one with no negatives. Although they're going to become negatives down here, aren't they? Maybe it was a dumb move, but oh well, we'll do it anyway. Y, take away the y value, so y take away 8, equals the slope, 9 over 8. X, take away the x value, which is 3. We want to put this in slope-intercept form, so I'll do this in a couple steps here. I'll leave the 8 over here for now. We're going to do our mountains, distributive property, expanding, and what we get is 9 over 8 times x is 9 over 8x, and 9 over 8 times, well, first of all, it's times a negative, so it's going to be minus. 9 over 8 times 3, which is the same as 3 over 1. I'll do it over here. 9 over 8 times 3 over 1, 27 over 8. So I know it's ugly, but that's what we have so far. Okay, last thing we need to do is we need to move the 8 over and add, so we'll have y equals 9 over 8x, take away the 27 over 8, but we're adding 8 to that, because the minus comes over and plus becomes plus. And let's make that 8 over 1 as well, because now what we have to do is we have to combine these two fractions. So we have negative 27 over 8 plus, we need common denominators, which will be 8. What do we multiply this 1 by to get 8? 8. So we need to multiply the top by 8 as well. We get 64. Yuck. As I said, it's going to be a terrible answer. So when we add those, the bottom stays the same. It's 8. Negative 27 plus 64. Well, you're going to have more positives and negatives. You have to actually kind of subtract them to get the answer. You're going to get 37. So we have y equals 9 over 8x plus 37 over 8. There we go. Now, that's in slope-intercept. That's a slope-intercept equation. If we want to write it as the slope-intercept function, what's the only thing different? Very easy. The only thing we have to change is this y should become an f of x. So f of x equals 9 over 8x plus 37 over 8, and we're finished. And I apologize for the crazy fractions in that question. Okay, there you go. A couple graphs on the next page. First one, graph the function g of x. You see it's not f this time, it's g of x. I just called it that. It doesn't matter. You can call it m of x, n of x, anything you want. Graph the function g of x if it equals x divided by 3 plus 4, and give the domain and range. Okay, so if you have an x value of 0, then what's g of x? Well, that'd be g of 0, right? If x is 0, g of 0. How do we figure out g of 0? We put 0 into this x spot right here. 0 divided by 3 is 0, plus 4 is 4. So g of x, or g of 0, I guess, is 4. Alright, what if we have g of 3? Because if x is 3, we want to find out what g of 3 is. Our input's 3, so we put 3 in here. 3 divided by 3 is 1, plus 4 is 5. What if it's 6? Our input's 6, or our x is 6, so we put 6 in here. 6 divided by 3 is 2, plus 4 is 6. Okay, how is this different once we get down here? Well, now what we're given is we're given what g of x is. This is the ones where we already know the output. We know the y, or the g of x. You have to figure out the x. So it's kind of like we're saying that all of this is equal to 3, and we have to figure out what the x is. In order to solve that, you would have to subtract 4 from both sides. 3 take away 4 is negative 1 equals x over 3. And then since it's divided by 3, we will times by 3 and times by 3. These cancel. You're left with x equals negative 3 times negative, oh sorry, this is times 3, that's not negative, sorry. This is negative 1 times 3 is negative 3. So this answer right here is negative 3. Last one, sorry if this is messy, I hope this isn't confusing you. Again, this is one where we have the output, or the g of x, or the y, so this is 2. And now we have to solve this. So we're going to take 4 away from both sides. 2 take away 4 is negative 2 equals x over 3. Since this is divided by 3, we're going to multiply by 3 and multiply by 3. These cancel. You're left with x equals negative 2 times 3 is negative 6. So this is negative 6 here. Okay, now we're going to graph all those points. So the first point, 0, 4. 0, 4 right here. Next point is 3, 5. 3, 1, 2, 3, 4, 5. 6, 6. Negative 3, 3, and negative 6, 2. And you can see they form a line, and you'd expect that. This is a linear function here. Okay, now the domain and the range. It's not totally clear from this question, but they give you some questions like this in the book. If these are the only x values, then these are the only points we're dealing with, right? We wouldn't draw a line through them because these are the only points that work. If these points are just like representative of the function and there's an infinite number, of course you would draw a line here, and then your domain and range would both be all real numbers. But in your book, they don't want you to do it that way. They want you to actually just look at these points and say what's the domain and what's the range of these 5 points. So the domain of these 5 points, remember we put them in curly brackets. The domain is negative 6. For this point, negative 3. For this point, 0. For this point, 3. And for this point, 6. The range, the lowest one is 2. Next one up is 3. And then a 4. A 5. And the last one's up here at 6. There you go, there's the domain and range. Last question, this is tricky. Use the graph of the function h of x. Well, you can see here's my graph h of x right over here. It says h of x right there. to find the following. Okay, first thing to find is domain and range. Shouldn't be too much problem there. The domain, what's the lowest x value? Well, this thing goes forever in this direction, so the lowest is negative infinity. What's the highest x value? Highest is right here up at 2. Does it include 2? Yep, it's a solid dot, so it looks like this. Or, if you wanted to write it the other way, you would say that all the x's are less than or equal to 2. The range, what's the lowest y value? Well, this goes down and down and down. It goes down forever, so negative infinity. What's the highest y value? Highest y value is right here at 4. Or the other way you could say that are all the y values are less or equal to 4. Okay, now it gets a little bit more confusing. This question says, what's h of negative 4? So what that's saying is, when you put negative 4 into this function, this is some crazy function, I don't know what the equation is even for it, but this is the function h. When I put negative 4 as my input, what's my output? Okay, well, the input number right here, this is like the x number right there. So we're going to go over to negative 4 in the x. 1, 2, 3, 4. Okay, along that line, negative 4, these are all the points that have negative 4. What's the point on the actual function that has an input of negative 4? This one. What's the output there? What's the y value of that? Negative 2. So h of negative 4 is negative 2. So I'm going to go through that again because it's a little bit confusing. What this is saying is there's some point on this green function here that has an input number of negative 4. So there's an infinite number of points on this green function here. Point. There's only one of the points that has an x value of negative 4, which is that it's this point right here. That has an x value of negative 4. That point is negative 4, and what's the y value? Negative 2. And that's why if you have an input of negative 4 in this function, what you get as your output is negative 2. Let's try another one of those. Input of negative 1. So where's the point on this green function that has an input of negative 1? So we go over to negative 1, and where's the point? It's right there. It's this big point right there. That point is the only one that has an input of negative 1. It has an x value of negative 1. What's the output there? What's the y value at that point? It's at 1. So that's why h of negative 1 is equal to positive 1. Okay, now we're going to do the opposite. For these last two, it says, when does h of x equal 4? In other words, when does the function have an output of 4? So this time, this is the y value. We're looking for which of these points here has a y value of 4. So y value 4, that's up here. We're looking in this direction now. Which point? It's this point right here. This has a y value of 4. What's the input value that gives you that value of 4? Or in other words, what is this? Name this point here. What's this point? It's 2, 4. So the input value, the x value that gives you an output of 4 is when x is equal to 2. X equals 2 is your answer here. What we've just figured out is that h of 2 equals 4. Is that true? Let's just make sure it's true. If you have an input of 2, if your x value is 2, your input's 2, your output is way up there, your output is 4. If you have an input of 1, there's your output. If you have an input of negative 3, there's your output. Right? It all goes with this green function right here. Okay, when does h of x equal 0? In other words, when does the y value equal 0? So we look on the y-axis, and where's it equal 0? Right here. That's where it equals 0. What is that point? It's 0, 0. So what's the x value that gives you an output of 0 here? It's when the x value is also 0. So our answer is x equals 0. Here our answer is x equals 2. What we've learned in this last question here is that h of 0 equals 0. Is that true? Yes, if you have an input of 0, or an x value of 0, then the output, or the y value at that point, is also 0. I know this last bit here is quite confusing. It might take a bit of practice in the workbook to get those, so come see me or ask me in class if you're having troubles with that. Alright, good luck with function. Very important. Grade 11 and 12 are pretty much all about functions, so you want to make sure you get this stuff down.
Psycho killer, qu'est-ce que c'est?